This is the Altair-Duino, and I didn't shoot video of my soldering of this entire kit because it's kind of my zen thing is to come in here and build a project. But I had to take this apart because I bought the standard version, not the experimenter's version, because I wanted the case. But if you do that from the wonderful creator here at the project Add Water and Stir. By the way, I'm going to call out this is a great kit, very well put together, very well documented. Highly recommend if you guys want to build a cool kit and play with an Altair, and I'll get some video of what this looks like. But um, I would I would recommend if you purchase the kit, go ahead and buy the SP module. In fact, the guy sells them pre-built and ready to go on his site. So I bought that, and I also bought that little expansion card. Setting me find a safe place to set this thing down here because I don't want to bend up the LEDs. I bought this expansion card to add in just so I could have example I/O. Now it's in a case, but I went ahead and soldered on the header here. And I've also got these DB9 and DB24 punch outs I could use in the future. So this expansion card has a ribbon cable on it that will provide the SD card access. You'll have a direct USB from the backplane here heading up to the programming port on the Arduino, and then this thing's feeding power to all the cards and the board through a little regulator here. Again, very well documented. It's not real complex to put together. I did add some supporting hardware on the Arduino because it seems a little heavy on that side, so the metric nuts I've randomly thrown in there, I've got 3 total, are not really necessary. The friction will hold that thing in place. But I figured I want this thing to last darn near forever. Again, really well documented and well put together. Now, I will say the only pain with this is putting the faceplate back on is it's a tough thing. So, because you solder those LEDs and you solder those switches, and they're going to be a little bit off from the actual panel, so you kind of got to do some finessing and be a little gentle, but it goes together. And I'll show this. I actually have a flat screen monitor that sets on top of this thing, and it supports really well. So I'm going to go ahead and get this thing back together, or at least get the face on, and I'll show that step. Oh, well, again, speaking of documentation, since I was adding the Wi-Fi onto this, there is a jumper next to the SB32, and if you pull it out, let's see here, when you install the SB, you have 2 options. So you can choose which pins it will connect the SB to on the Arduino. So A6 and 7 will require removal of the SP3232 chip, which will remove our DB9 serial externally. If I used pins 18 and 19, which he has shown there, I'd have to remove the PIC32 controller on the expansion board, which I am not going to do, because that is the built-in terminal emulator that gives me VGA out for my terminal. And because I'm using this with its own monitor connected, I'd much prefer to have that PIC doing that job. So I pulled out the 3232 chip, put it on a nice anti-static bag. In the anti-static bag, wrote a note on it that I removed for SB32 Wi-Fi serial, and I will toss it in there. Okay, so from the rear of the chassis, you can see the SD card loads in. Barrel connector for power, DB9, which is dead now, programming port for the Arduino, USB for keyboard, and then the dumb terminal emulator, which is using VGA on that PIC. So I wanted to show real quick this clever. I've had one other acrylic project that does this, where the acrylic case has, so there's a spot to put your square nut, and your screw goes down through the nut, but you have to center it. So it ends up looking like this when you torque it down. It's cool, but I want to show you where that can suck. 2 of these are inside, so you have to very carefully lay the nut in there, and then you lay the top on and carefully thread the screw and start it, and then you can torque it down. You're good. Inside the chassis, I bent the ribbon cable to make it look a bit more attractive, but you got a ribbon cable right here, and that connects your display board and the Arduino to this expansion board. And then you've got your programming cable, which plugs in next to the barrel plug. And then you also have, down there you can see that black cable that connects this board and the expansion board for power. Again, it's all very well documented, pretty impressed. And then, of course, these jumpers are easy to get to now. So the SB sets right there are kind of in this void should I choose to add more stuff in this thing. And I will be building more expansion cards. On the creator's website, there's a hard drive controller expansion card from Add Water and Stir. God, I can't talk. So this is the only other card. Is this, the hard drive controller, which I have no use for, or floppy drive controller, whatever it was. And then there's this little expansion card for LEDs, which of course is not too useful right now, but I'm going to build something and I'll take those LEDs off, or I'll use the jumper. And there's a header on it where I could get output signals as well. Anyhow, I wanted to have the ability to play with it later, and 10 years from now, who knows if the project will still be around. I was like, I'll just build the stuff now. There is a GitHub page with Gerber files and everything else for some other cards, like a different serial port adapters, and also what was the other one? There was a voice generator. So there's like a little speech synthesizer. It seemed like it'd be kind of fun to play with. But like I said, since I got these 2 DB9s and 2 DB24 connectors on the back, I can pop out, and I can just take a standard. I've got one on the shelf here. So a DB9, I can just unscrew those and pop that in there and have a DB9 port. Right now there's no header to connect it to, so that's not something I'm doing at this point in time. I'm just setting up the Wi-Fi telnet, so continue on the assembly. And this is what the unit looks like before you put the beautiful little decorative face on. The system's held in place. There's this piece of clear acrylic that's attached to this sideboard, and it's got a plastic nylon screw, nylon like 3mm standoff, nylon 5mm past that to hold the face. On the front, there's some jumpers where you specify the 8800 or the 8800B here and here. And then you can see, again, I added this hardware. This isn't part of the normal kit, and I don't know if it's even necessary, but I felt like I wanted to have some extra security for that because I want this to last forever if I can help it. Be a little more vibration tolerant. And then this guy is just really well designed. Now, the only thing I'd say is the LED placement was a little hard. You can see some of mine are bent. That's just how they're going to be permanently now. You don't notice it when the front panel's on, but soldering these in, the problem you run into is there's a little bit of slop, in very, very little slop. So your switches, if they're off by just a little bit, they're going to be straining against the plastic. So when you put it together, you might have to find yourself pulling and wiggling a little bit just to get everything to fall in place. The LEDs are much easier. It's a rounded top, so they kind of feed themselves through the hole. Very easy for that. Those almost perfectly line up. I would like to have the little plastic doodads that stand off for these. I did see that on some of the pictures online, so maybe it was just a cost thing, or it was just they didn't help at all. I don't know what the deal was, but doing it this way works, but it feels kind of weird to just have them hanging out there. The red switches on bottom are down, up, and they're momentary up, momentary down, rest, and center. The blue switches are up and down. So I think these are all single pole, single throw. I think these are all SPSTs. Oh, sorry, single pole, double throw. So I think these are all SPDTs. So I'm pretty sure every one of these is a single pole, double throw. I don't think any of these are more complicated than that. But very clean. If you looked at the older versions of this board, you'll see a bunch of like resistors and stuff. The creator mentioned he's gone to a better setup for this. You've got these resistor packs and stuff, and I didn't frankly read how he redid the drivers. I was just very impressed with how clean the board is. It's beautiful. It was very easy to assemble. There weren't a ton of ridiculous components. I just say the biggest pain in the booty are getting these soldered in, and the LEDs, and of course the sea of pins for the Arduino. You even use the ones in the center. I mean, that thing is a bear to pull off. But again, to the credit, the guy's like, yeah, put all the jumpers on the Arduino, then land it on the board before you solder it in place. And thank God you did, because I can only imagine that would be impossible to get everything to line up after the fact. So I want to show this this faceplate. It's going to set over, and I'm just going to show you how it doesn't just magically work. So there's the LEDs. They're going to kind of go in real easy like, but see that the switches can be, it's just not something you can just push on. So I got to have two hands. You got to be gentle and sensitive and kind of finesse it on there, and I have to push my hand on the back of the board to kind of put some pressure on back of these switches, because I don't want to be flexing this board the whole time I'm trying to force that panel on. The good news is, because he's made it so tight, the holes for the switches, you don't actually screw down, because I figured we were going to take these screws off and put screws in the front to hold it against the panel. You don't do that. they just rest, and it's so tight against here with the threads that it doesn't move at all. I've sat here and I've flipped these switches, and I'll show you here in a bit, but it's actually pretty impressive how you don't need to put any nut on the front panel. It would really suck if you did to get in here and try to change anything. So anyhow, let's go back to assembly. I got some screws in loose, and you can kind of see how the LEDs just sort of find their way through, but look at the switches. They're sort of like, very much not through there. So what I'm about to do is, and you can see they're not centered, and this is my doing. The instructions tell you to put the front panel on when you're soldering in the LEDs to kind of get them to fall forward, and you solder it with the LEDs resting against the panel with the standoff in place. So you take this assembly here, from here to here, and you're laying it face down, and you're soldering the back of the LEDs as they lay into this panel. And that works really well to get them all set at the same height. It worked perfect. The issue is the switches did not have the same instructions. So I whacked those things on and did not lay the front panel down with the... I actually don't think you could, because there's a really tight fit for the posts. So there's 3 posts per switch, and when I was putting these on the board, I was holding the back of the board, the back of the PCB, and I was shoving with the other hand to press fit those legs into the board. It's a great tight fit, especially considering you're going to have fatigue on the solder sitting here doing this and switching. So I'd rather it be a tight fit and have to go through this than have it all loosey-goosey and just depending on the solder and the printed circuit board traces to hold it in place. So the mechanical compression holding those contacts into the board, the downside is you don't get it to be perfectly lined up. The positive is it's mechanical tension, not just the solder mask and everything holding it in place, the switch. So I feel like you get a better assembly that way. But that being said, this is what you're going to end up with. You are going to have to finesse this in. So just take your time, jiggle the switches and get everything kind of fit back in. I'll show you how it looks here in a second. All right, there you go. Doesn't take long at all, but now you can see you got maybe like 1 thread out for each switch across the board. And then I have to wipe off my dirty fingerprints from here with some distilled water and a tech wipe. But all right, so let's go ahead and finish assembling this thing. And you can see now, by the way, how it looks. It's a pretty little piece of kit once you get it all put together. I'd highly recommend this. Just an absolute charm to play with. I figure I'm going to show what I do with these. So take a needle nose and just kind of gently get Mr. Square Nut in there. There you go. And you're going to do that on each side, and then you'll do the one here in the back. And with this one, you can kind of just use your fingers to get it set in there. I'm doing this looking at the camera, so don't judge. But that's how you're going to set it. And then the plastic lid is just going to set on top, and you're going to gently lay the screws in on all 3 before you torque anything down. Just gently turn, get the threads started. You can kind of feel it and grab on it until it's in there. You don't want to torque one down and be like, oh, now that one's in the case. Got to take the whole thing apart again. So gently find the threads, get it started each time. All right, let's boot up the old Altair. Boop. And then we have monitor output. Let me remove that so we don't have that on screen. There we go. It's a little better. Still getting a bad reflection. I've got a lot of lights in here. Let me see if I can kill that one. Let's see. Boop. Huh. Okay. Yeah, I chose red. I'm sorry. Tell you what to do. Hold on 1 second. There we go. Put it in the dark. Whew, lens might be dirty too. There we go. That's a lot better. Okay, so if I pull down with all switches in the 0 position, I pull down on aux 1. That's going to give me a listing of programs. So there's some basic stuff you can do. I mean, real basic is in like entertaining. Let's see. I'll throw on the CPU diagnostic here real quick, and then boop. CPU is operational. Well, thanks for telling me. That was nice and quick, wasn't it? So let's see. Stop. Reset. Clear. Push down on 1 again with everything in the 0 position. Oh, that was not what I wanted. I had been running the time sharing basic. I did the wrong thing. Sorry. Wrong switch. Put that back to 0. There we go. And okay, not going to get into that here. So let's see if we fire up the, where is it, Pong terminal. You can play Pong on it by default real easily. All right, very easy to do. That, we'll see it stop. And then reset clear, pull that back down. How about the I'm not gonna boot any operating system right now. We'll do 16K basic. We'll do that and boop. Memory size, you can just push enter to use all available. Line printer, I'm gonna put O for Oki data, and we are in basic, so I can do print 2 plus 2 is 4. Yeah. Not super crazy there. So there we go. Now I'm going to work on the serial Wi-Fi thing. We're going to see how well that works out. So let's just do the stop reset here. Where's it at? Reset clear. Ooh, oh, I didn't do it while it was stopped. Oops. Reset clear. And then, oh, that made it mad. Yeah, don't. Oops, wrong switch. So I kind of quickly reset it while I was in the middle of running something. But yeah, this is really straightforward and fun to play with. Provides a lot of entertainment. I've been enjoying playing with old basic programs. Running Zork on this is really entertaining. So if you guys want to play Zork, it has CPM, and there's a bunch of CPM games and stuff. I think is it this switch and down? Yeah, so there's the discs that are in this by default. I'm not going to show how to like mount and boot, but there's CPM, Altair-DOS, and I flip this bit again here, and then hit aux2 down again. Oh, wrong one. Did that wrong. Let's see, reset clear. Stop, reset clear. Let's try those two, aux2 down. There we go. So there's the hard disk images. There's a hard disk basic, Altair counting system, Mike Douglas's 88 hard disk, CPM, Infocom Adventures. And then do this and then that. Wrong one. Stop. Let's see. Reset clear. Don't remember what I had to do to get to the other. Is it these two? Yep. Tarbell. So it's octal, by the way. All the inputs. I have to remember what octal number it is for each of these. But anyhow, as I'm setting the switches here and then hitting aux2. So this is the available Tarbell images. So what you do is you mount one of these, and then from the app menu here, you input one of these, and you can use aux1 to run the either hard disk boot ROM, Tarbell boot ROM, or the multi-boot bootloader. So anyhow, hope you enjoy that. But the Altair is quite functional, and like I said, I'm going to go jack with the serial thing on the Wi-Fi and see how this works. And I won't be able to record it because I use my cell phone to shoot the videos, and well, I'm going to use my cell phone to talk to the SP. So that's what you're going to get for the day. We soldered it in, and there it goes. Okay, so a couple lessons learned. I was going to use the A1, A6 pins, but that was going to break my ability to use this little, this little serial chip in there. And there's also right next to a PIC Micro. Well, the PIC runs the VGA. The little tiny chip runs this DB9. This programming port goes straight to the Arduino. I'm going to be using that for programming, obviously. So the dude who the project maintainers are geniuses. Apparently you can use the transmit and receive pins, which can be independently sent signals of the actual port utilization, and they've turned that into a serial port. So what I've done is I took some Kynar wire, I soldered it, and then I kind of did 2 hot snot tacks on the board, and so hot tack 1 going across a bunch of stuff, and tack 2 here, so like it's flat, looks pretty. And then I have a little bit of curl there. Longest strain relief, or longest heat shrink tube I had that was short, and another big heat shrink tube, and I soldered on a 2-pin header, and then I've got a female to female jumper, and I did it really tight because I don't want any slop or jiggling around in there, and it is glued just with not super glue, with hot glue. It was just hot glued right there. I think I always peeled off, won't hurt the board, but that kind of holds this in place. And then if I want to take this board out, I can still pop those 2 pins off, undo that USB, and I'm done. It can still come out and be, I don't know if I have to solder something else on it. As you can tell, I put the screws in it. I don't plan on taking this thing out anytime soon. I've intentionally got it really tight in there. Things to note, I did notice that there is a pin from one of the LEDs that gets underneath that bracket. You can just barely see. Puts a little bit of pressure on the top of that. I thought about getting there with the snips, but I'd already bolted everything down. There's just a little bit of flex right here on the end of the board, but it's fine. It's a power connector. Who cares? The overall thing is pretty cool though now. So if you consider you've got VGA output with USB keyboard, that's one serial port. This is another serial port for DB9. You've got the programming serial port. Technically, you have the native USB port that's in here. You could also use for serial. And then I have the little doodad in here that's providing me the Wi-Fi using the transmit and receive pins. So I have another serial port through that. In total, though, for me to use, though, 1, 2, 3, that will actually be used for interacting with your Arduino. And that's going to be cool in a time-sharing system because I can load up Altair's time-sharing system and have the Wi-Fi be a terminal on the rest of the system. So hope you enjoy that. Really cool project. I will say I did have to recompile. There's an easy method, and it's not slight against the developers. They've done a great job making everything very easy to figure out. So, like, really well done project. Documentation is amazing. So this you have to. The easy method did not have it compiled to what it claimed that supported the LED thing. So I had to recompile it, enable the LED setting, and then I also enabled the A6, A7 little tiny output here. When you do the A6, A7 enablement, the protect unprotect switch is disabled. Oh, point of note, the third connector down here is the protect unprotect switch, and these two little pegs right next to it, it has a 1K resistor. All the manuals call out and they say, for the love of God, if you enable A6, A7 for that little RS-232, DB9 deal, please ensure you disable the protect enable disable switch because you'll burn things up. So one of the things the author mentioned in the manual is like, well, you could solder a 1K resistor on the ground. It looks like on this board revision that's been done. I checked it out with the ohm meter. Everything else is 0, across all center pin on the lower switches, but that one switch is a 1K to the ground. So I was like, okay, cool, already protected. So if you're worried about that, reading the manual, see all the warnings. You're good if you've got the newer board with the one I've got here. And then the as far as the LED thing, I would recommend that. It was cool. It was easy to do, especially if you got some Kynar wire. You can do it really pretty, and it's I don't know the manuals. I don't think they had Kynar. They had little cheap, like, it looked like they tried to use real thick cables like this. Somehow they pulled it off and made it look good still. But yeah, Kynar was very easy, so you could kind of really shove it in there and make it look like it was a factory bodge. All right, well, yep, compiled it, set the settings, used the programming port, pushed it, following instructions. Didn't have to use a brain a whole lot on this other than figuring out why the hell it wasn't working. So, really cool. See y'all later. So with the lights off, it has more of a pretty light show. I had a junky little basic program I wrote for this based on the LED flashing program for the adding card. I'm using the Altair time-sharing system, which is included in the notes and the drive. So there is a ability to run multiple terminals and have this thing run as like a time-sharing, mini mainframe. It's not, wouldn't dare call it with the limited memory it has. But seriously, if I type list, you can watch the lights flicker as I type LIS. I'm doing this one hand. T, and when I enter, it's going to load and list that program, right? If I do run, RUN, see, it starts kind of flashing away as it's thinking. And then if I go here to the telnet session I have running through the Wi-Fi card and do the same thing, I'll tell it to run. And that's a random number generator. That one is just doing that one's just doing count. But you see, you get much more of a flicker. It's not showing up as brightly on the camera here, but it's pretty cool to have some blinking lights. And Control C here. Kind of see some real. Has doing that count seems to be much less stressful for it. I'll turn the count back on here so you can see it run. And boop. Oh, there it goes. So you see that it's a nice flash, 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 flash. And then if I do this run on this random number generator, it seems to get a bit more strain as it has to think. It was pretty cool though. So I've got there's a session not showing you on the other thing on the Windows machine running over Telnet. So the wireless connection is emulating a terminal, and it's using the receive and transmit LEDs I showed earlier. I had to reflash the firmware with the program report in the back. was very easy to do. It wasn't complicated at all. I've played Zork on this for a bit. It's been pretty entertaining. I guess it's my favorite. Of all the computer kits I've built, this one is fun because it has a bunch of vintage software you can load on it, and I think that you see the 68K box setting here I still play with. I just, not every day I'm going to get out and write something from scratch in assembly. That's a little bit more involved, and I'm not... It's fun, and every now and then you get the itch. This is cool. I can fire it up and find an old game somebody wrote, or a basic program, and just run it. And, I can compute like it's 1978. The switches are very nice and tactile. It's got a good click to it when you flip them. Obviously not doing anything right now, but if I hit stop, it would stop the entire time-sharing system. And I've had this running for a couple days. My goal is to see how long I'll keep this thing up. Just sitting here doing silly things. I'm wondering about doing. I think I mentioned in another part of the video. I wanted to see if somehow I can tie this into rendering a web page. Some people go and request a website, like the content is being fed from this. I know I couldn't actually probably have a web server on it, but I could obviously have it send out a string of text that I could somehow parse and turn it to a web page. So I don't know. I'm gonna play with that and maybe even turn it into like a telnet service. I don't know. I'm just, it's hilarious to me. It's a very cool toy, so I hope if you were considering buying one, I've given you the itch. It is definitely worth the money. And with the lights on, kind of see it a little better. But, yeah. Booting is pretty easy. In this case, I don't remember what disk the time-sharing OS was, but I'm pretty sure it was, I think it was this switch I have to flip on 12. The nice thing is the documentation is very clear, so I'd have to look here. I printed everything off. There's actually an entire set of instructions in the guide on how to boot Altair Timesharing OS, which is very handy. And then I printed the MITS Timesharing Basic Reference Manual. That's for version 2. There's the Timesharing Reference Manual for version 1. The logo is kind of cool. And then there's the sundry there's what I was looking for here. This on the SD card and in the GitHub there will be a list of available disk images. So time sharing basic v2 right here. This disk 0A 0101. So that would be bip bip like that. And then once you've got it ready to load the disk, which I think would be that one, be pop down on aux2. Flip that down, and then this is going to boot load, and you flip down on aux1, and boots right up. So, very easy to work with if you want to play with time sharing. They made it where you could be really lazy. You don't have to, like, hand click in a bootloader. If this is real hardware, and it didn't have a ROM in it, then you'd have to go and tell it how to bootstrap, how to read the tape, all this stuff, like, depending on the loadout you were emulating. You can see videos on YouTube of the originals. It's a bit more effort, so hope you all enjoy this. I know I sure as hell have. So check out the thing. Add water and stir. It's AD water and stir, not ADD. So AD water and stir. Add water and stir. I'll put a link in the description, but I'd highly recommend you check this out. There are two different kits. There is this. I forget what he calls this. There's this kit, and then there's like the Experimenter's kit. But the Experimenter's kit doesn't come with the nice chassis. The thing with the chassis, though, is it's closed up. But I would argue I'd rather have the chassis because I could just open the top and leave it open if I want it to be an Experimenter. Because what I do is I have the card you'd have from the Experimenter, and I also have the Wi-Fi card. The Wi-Fi card, I think, was it on this side maybe? I don't remember which side it is because now I've closed it up. But it is $5 from his website to get it pre-programmed. I was like, I'm not going to bother with getting the SP programmer then, because if I can pay somebody $5 just to send it to me pre-programmed, it's almost the same as ordering it from Amazon. Yep. So there you go. See ya.